Okay, it's just past 10 o'clock in Central European time, so I think we'll get started. So welcome everybody to the next in a series of webinars we have on the European, European Weather Cloud. These webinars are joint between ECMWF and EUMETSAT. And today we're going to be talking about using object storage from customized instances in the European Weather Cloud. So in this 1.5 hour webinar, we have two presenters. We have Samuel from ECMWF and Usa from EUMETSAT, and they're going to do, Samuel will present first, followed by Usa. At the end of each presentation, there will be opportunities for questions, but throughout, please ask your questions in the chat. We have a number of colleagues online to answer your questions in text form. So with that, we'll get started. So I'm going to hand over to Samuel. Over to you.
Thank you, Becky. Hello, everyone. Welcome to this webinar. So my name is Samuel Langlois. I work at ECMWF in the user support department. And today with Usa, we're going to talk about using object storage from customized instances in the European Weather Cloud. So I will first talk about customized instances. Then I will leave the floor to Urusa to talk about using object storage. Quick agenda. So first I will quickly do an overview of the European Weather Cloud. I'm sure most of you know already what this is about, but there's always some newcomer, and it's always nice to refresh our memories. I will do a quick recap of the last episode as well, the previous webinar. It's like a TV show. You have a recap. That's because I'm going to build up on that, on what we did last time. So I just want to refresh everyone's memories again. Then I will talk about instance types. What are they? What can we do with it? And there will be a demo where I will build our own instance type. So just quickly, what is the European Weather Cloud? European Weather Cloud. It's a joint service offered by ECMWF and EUMETSAT. It's a cloud offering. The goal is to bring the computing power right next to the data. So at ECMWF and EUMETSAT, there's a lot of data. There's petabytes of data, and this cloud offering is to bring computing power right next to the data, so you can easily treat this data, work with it. It's very much a community cloud, and so here is the architecture. I'm not going to go too much into details here. What you need to know is there are two sides really. There's the EUMETSAT side and the ECMWF side, and depending on where the data you're going to work on is, you're going to be rather on one side or the other side. However, both of them are managed by Morpheus, which is a cloud orchestrator, and both sides of the cloud are using Morpheus as the primary interface to interact with it. I will be using Morpheus in the demo to deal with the instance types. If you don't have a tenant in the European Weather Cloud yet, and you would like to have one, you can, if you're from a member state of either ECMWF or EUMETSAT. The procedure is very simple, but basically what's explained here is we need an authorizing officer, which is usually the computing representative of your country, to authorize the creation of the tenant. So either you are this authorizing officer, this computing representative, and they will ask us to create the tenant, or you ask us directly, but we will have to ask an approval from the authorizing officer in your country. Another side of the part of the European Weather Cloud is the community chat. So we're using Rocket Chat, which is very similar to Slack if you've used it. Anyone can log in there, and it's very much, again, to foster the community and have people help each other. And of course, in the support department of ECMWF and EUMETSAT, we do keep an eye on this chat and we can answer your questions when there are some. Okay, let's do a quick recap of the previous episode of the previous webinar. It was Xavi who presented. I just stole one slide from his presentation. I'm not going to go through all of that, but basically I've highlighted the last part, which was the workflow in Morpheus. So that was the final artifact that we created last time. A workflow in Morpheus is a process that you can run when you create a virtual machine. And what was built last time was a workflow that installs JupyterHub, configures it, all of that from a Git repository, which is public, so you can have a look at it. HTTPS certificate as well, so we can reach the JupyterHub remotely. All of that to work on the data from the European Weather Cloud. So today we're going to reuse this workflow, but we're going to use that in an instance type. So let's talk about instance type. What's an instance type? If you've created a virtual machine on the European Weather Cloud already, you've probably seen this screen. It's a Morpheus panel, and it shows you, it's the first question you see when you create a virtual machine. So you have the choice between Rocky and Ubuntu. So these are instance types. So an instance type is just a group of layouts, and that will orient the content of your virtual machine after that. So once you've selected the instance type, you have to select the layout. What is a layout? The layout is what defines really what is being installed on your virtual machine. So here on the screenshot, it's a screenshot from, if you pick Rocky as the instance type and 9.3, you have the choice between three layouts, the generic, the data, and the GPU one. Generic is just Rocky. Data is additional software from ECMWF to handle your data, so MedView, EC codes, Mars client, etc. And the GPU has additional drivers to handle GPUs. What interests us here is that the layout allows you to define the workflow in Morpheus. So that's when we are going to reuse the workflow from the previous webinar. Once you've chosen the layout to create the virtual machine, it will point to one node type. So what is a node type? The node type is basically, in the Morpheus world, it's a pointer to the virtual image. So here, the screenshot is the previous virtual machine that we created in the previous webinar. And you can see that it's going to it was created using the source image Ubuntu Jammy 34, and we're going to reuse this image in the node type today. So all of that is a bit confusing. This is the best description I could find from the Morpheus documentation. So you have three layers. The instance type is at the top. It doesn't define much. So here in this example, we want to create a virtual machine which has an Apache web server. So the instance type is just choosing that. I'm going to create a machine with an Apache web server. The layout defines everything. So the version, you can have different versions of the Apache web server, 2.4, 2.3.5. And the node type defines basically the OS. So whether it's CentOS, Windows, etc. And so today we're going to go through these three layers to create our JupyterHub instance type. How does it help? How do instance types help? As a tenant admin, it's a way to easily package all your components together, standardize the version, and you offer that to your users. And your users then makes their life easier because it's easier for them to create a VM that matches the standard of your organization on the version that you want them to use. So the plan for the demo is we're going to use two personas. So the first one is the tenant admin, the first name tenant, last name admin. And as the tenant admin, I'm going to create the 3 layers, so an instance type, a layout using the workflow we've defined in the previous webinar, and node type that will point to the Ubuntu image that we've seen. And then I will switch to John Cloudy, who is our European Model Cloud user. And John Cloudy is going to create an instance based on what was defined above. And then hopefully John Cloudy can use Jupyter. Time for the demo. Okay, so we have here Morpheus, and I'm going to use 2 browsers. So this is Firefox, and I'm logged in as the tenant admin. You see that at the top right here, tenant admin. And then I'm going to use Safari as well as logged in as John Cloudy, top right John Cloudy. First, the tenant admin is going to create an instance type. So this is located in library. So in the library menu at the top, blueprints. So here you have the list of instance types. Currently there's none. You have instance types defined, but they are not in this tenant. They are defined for the whole system. But this tenant currently doesn't have any instance type. So we are going to create one. So let's click on the add button here. Okay, so we need a name. I remember the instance type is just the basic overview. So it's just going to be called JupyterHub. We need a short code, which is JupyterHub as well. Description is always nice. I'm going to write here. JupyterHub is JupyterHub allows to easily getting there. Create an instance with all ECMWF software installed. Okay, we can choose a category for the instance type, which is a kind of tag. I'm going to put apps because Jupyter is a kind of app. Just for my own sake, I will choose the webinar label so that I know I can delete it later. We can set an icon for the instance type, and I happen to have a Jupyter icon just here. So I'm going to use that. And we don't need to change anything else. So let's save the changes. And now we have our instance type. It has a nice logo, but of course it doesn't define anything yet. So for that, we need to go to the next level, which is the layout. Sorry. So creating a new layout. The layout defines everything, as you remember. So the name will be JupyterHub Ubuntu. And we could create different layouts for the same instance type. For instance, we could create a JupyterHub Rocky, or we could create a JupyterHub Ubuntu for another version of Ubuntu. We're just going to create one here, but remember that there could be several. The version is 22.04. I'm going to set the webinar label again. The one thing we absolutely need to change is the technology because we rely on OpenStack under the hood. So we need to pick this one. And the workflow, we of course need to point to the one we defined in the previous webinar, which is install JupyterHub, which installs everything. Okay, we don't need to change anything else. So let's save that. So we now have our layout. And as you remember, there's a third layer below that. So now we need to define a node type that will be used by this layout. And that's when we're going to point to the virtual image. So clicking on the layout, there's no node type yet. Let's click add. Okay, so remember the node type is not specific to JupyterHub. So we're just going to call it Ubuntu because we may reuse this node type one day to install something completely different. So the name is Ubuntu -2204. The label is still webinar. We need a short name, which will be Ubuntu -2204 again. And then the version is 2204. The technology is already chosen. I cannot change it because it's linked to the layout where we chose OpenStack already. And the main parameter is the VM image. So you remember we wanted to point to the Ubuntu Jami virtual image. Fortunately, we have all these hundreds of images which are provided by Morpheus, so we have to find ours in the list. There it is, Ubuntu Jami 34. Okay, and we don't need to change anything else. Okay, so now we have defined our instance type and everything underneath. It's nearly there. There are still two small things we need to do. There's one thing I forgot to do on the instance type. Let's go back to the instance type. I'm going to feature it. It's just a flag, and it allows Morpheus to present it on the first screen when you create a new VM. So it makes it, it features it basically, yeah. The other thing is we need to make sure that our user, John Cloudy, has access to this instance type. As the tenant admin, I can have a look at my users on my tenant, and John Cloudy is here. His role is demo. If I click on his name, the role is demo, and the instance types are here. So you can see the available instance types, and including the one I just created, JupyterHub, and you see the access is none, so that's not good. We have to give John Cloudy access to this instance type. So that's through the role. So let's click on the demo role. Okay. Yeah, and now on the list of instance types, you see JupyterHub here. The access is default, and default is none. So that's not good. We just need to change that to switch to full access. And now that should do the trick. So now John Cloudy will have access to this instance type. We can go back to the list of instance types. Okay, so we're ready. Now we can switch to Safari, and now we are John Cloudy. So John Cloudy already had an instance. By the way, it's the webinar instance that we created in the previous webinar, but we're going to create another one, this time using the, the instance type we created. So click on Add, and here we see our very nice instance type called JupyterHub. It has a description, and it has a fancy logo that we set. So we're going to pick that. Next, we have to give it a name, obviously. I'm going to call it Webinar 2. I'm going to give it the webinar label again, and I can pick an environment. I will pick test. Okay, next. And now we have to choose the layout. Of course, we only have one layout. And you see the version is not displayed either, but that's because we only have one version and one layout. But otherwise, we would have to pick the version we want there. But here the layout is just JupyterHub Ubuntu that we created. I'm going to pick a machine of reasonable size for CPU, 8 gig mem. Okay. I have to select the network to make it reachable from the internet, so it will be external internet here. And I have to pick a security group to open the port we want, so SSH, HTTPS. That's all we need here. We don't need to define anything else on this VM. So here is the summary. I'm happy with that. Let's create it. Okay, so now the machine is being provisioned in OpenStack underneath. We can see it in the list here. If I click on it, we have a very nice progress bar. We see that it's in the provision phase. It's preparing resources. If I click on history, I can see that it's in the provision phase. Let's wait a bit. It's spinning hard. So after a while, the provision phase will be done. So there we are. And now we're in the post-provision phase, which is the one that we're interested in, because that's when the workflow is going to get applied, the workflow from the previous webinar. So if we open here, we can see the log. So it's a typical Ansible log that we see here. So everything looks fine. If we click on the little eye here, we see it with color, which is even nicer. And we can see that it's currently updating the system, the Ubuntu system. So that takes a bit of time. What we see here just above is the host name. So that's interesting. We're going to select that and copy it. We're going to use that later to reach the machine once it's there. Okay, I'm going to close this. And we'll just wait a few more seconds, hopefully, for the machine to be here. 7 seconds exactly. Okay, there it is. So it's running. It has a very nice green tick on the health. So now we can create another tab, paste the host name, and there you go. We have our JupyterHub. It was all installed properly. I can log in. So it's JupyterHub as it is installed uses local users on the Linux box. So it's users that you define in Morpheus. In your Morpheus user, you can define your Linux username and password. So I'm Clay Cloudy here, passwords. And there you go. You have your JupyterHub ready to be ready to download some data. I'm not going to show what we can do with it. You can look at the previous webinar for that. I think that's it for the demo. I'm happy with that. I'm done with my part. Do you have any question on this part before I leave the floor to Olusa? I don't know if there were questions online. Yeah, as now?
Yeah, I was wondering, you have shown now very nicely how you do that through the user interface, graphical user interface. I guess there's also a way to automatize it, some scripts so that you can load them.
Yes, Morpheus has a command line interface as well that you can install, and that, yeah, I haven't tried that, but you can most probably do everything I've done on the UI and automating all of that using the command line. Yeah, I guess so. Another question. Sorry, I can't see.
Yeah, there's another hand raised by Pierre.
Go on. Yeah. Oh, okay. Okay, there will be another chance for questions. Permission issue. Yeah, okay. Do you want to type your question in the chat? What about updates of ECMWF software? So all the ECMWF software which we installed here was part of the workflow that we defined in the previous webinar, which yes, so that was based on an Ansible playbook. So the Ansible playbook, you do whatever you want with it. So you can upgrade the software whenever you want to. Python packages must be kept up to date. Yeah. Go on, Shai.
Yeah, just very quickly, just to complement on what you said, Samuel. So the ECMWF software like MapView codes and so on, this is installed as part of a Conda environment. So which to which you have access as if you are administrator in the machine, and then you can update it like any other environment, or produce an extra environment with new versions if you don't want to disrupt the existing installation. Mars client will be updated as part of the usual updates on the system because it's installed as a system package. So anytime you update the machine, if there's any new version of the Mars client, that it will also be automatically updated.
Okay, but then updating is done by hand for all conda-related stuff. That is fine. Thanks.
Yeah, usually you don't want to, well, automatically update packages that might then break your workflows. So, you normally want to be a bit in control of the versions that you're using. Because sometimes, especially in the Python ecosystem, when packages update, it is not uncommon that things break, and then you need to tweak your workflows or scripts or existing programs to make them work with the new versions.
Yeah, no problem. Okay, I think that's all for question. I'm going to stop here for my part, and I will leave the microphone to Rosa for the next part. Go ahead, Rosa.
Yeah, thank you, Samuel, for the wonderful start to the training session. So yeah, my name is Urusa, and I am working for EUMITSAT. So I am gonna share my screen first. And this one. Yeah. So I'm gonna do this live presentation thing. Yeah, I hope you can see my screen now. So basically, I will start with the introduction to Amazon S3. So yeah, here we are going to understand the basics of the Amazon Simple Storage Services. Starting with what is S3. So S3, Amazon S3 stands for Simple Storage Service. It was launched by Amazon Web Services in 2006. So S3 is a cloud-based object storage service designed to store and retrieve any amount of data and information from anywhere over the internet. So it is known for its scalability, security, performance, and high availability. Amazon S3 is built on a few core concepts. So buckets are the containers that stores objects, as you can see from the little picture I have drawn, which are the actual files. So, and each object is identified by a unique key within the bucket, and S3 buckets can be created in different regions, so which are basically the physical locations around the globe where the data is stored. So these are some of the core concepts here. It includes buckets, object keys, and regions. So why do we need to use S3? So S3 has the option for designed for 99.9999, like there are 11 nines% durability. It is also cost effective, so you only have to pay for what you use. It has scalability. That means you can automatically scale to handle any amount of data. It provides high availability with multiple storage classes, and it has security. So it has comprehensive security and compliance capabilities. So it is also flexible. It has flexible storage management and simple data transfer. So just to summarize, Amazon S3 offers several benefits. So it automatically scales to handle any amount of data and is designed for 99.999% of durability. It provides high availability with multiple storage classes, and it ensures that the data is always accessible. So S3 also offers comprehensive security and compliance capabilities, making it a secure option for storing sensitive data. Additionally, it's cost effective, and as you only have to pay for what you use. So for the flexible storage management, Amazon S3 provides unlimited storage capacity, allowing you to store as much data as you need. So it supports a wide variety of data formats, including images, texts, videos, and backups. So it also allows for the easy organization of data using the buckets and folders. So you can also have some of the lifecycle policies which are enable automated management of of data, such as moving to different storage classes or deleting the data after a specific period. And as per the simple data transfer, you can always easy to upload and download the data using the web-based consoles, command line tools, or with the programmatically using these APIs. So it also supports multi-part uploads, which enables efficient and faster data uploads, especially for larger files. So these are some of the uses of the S3. And some use cases. So Amazon S3 is versatile, and it can be used for variety of purposes. It's commonly used for backup and restore operations, providing a reliable solution for data protection. So it serves as an excellent option for data archiving to store the long-term data, and it provides a reliable solution for data protections. It serves as an long-term storage at a lower cost, and S3 is ideal for big data analytics, which as it can store and analyze large data sets. And additionally, it's used for the content storage and distribution, so making it perfect for storing like static contents or for websites. And finally, S3 provides a secure and redundant storage solution for disaster recovery. So let's go through some of the differences between traditional storage as well as the S3 simple storage service. So traditional storage solution typically requires on-premises hardware, which involves significant upfront and maintenance costs. These systems have scalability limits, making it challenging to handle the growing data needs. In contrast, Amazon S3 does not require any infrastructure management and offers virtually limitless scalability. So it operates on the pay-as-you-go model, and eliminates the need for large initial investments. So additionally, S3 is accessible globally, providing greater flexibility compared to the location-bound traditional storage systems. And some of the security features in S3 are like Amazon S3 provides robust security features to protect your data. It offers data encryption at rest and also in transit, so ensuring that your data is secure in both, when it is stored and when transferred. So S3 also provides like fine-grained access control policies, allowing you to define who can access your data and what action they can perform. So it has also detailed logging and monitoring capabilities, which help you keep track and access and usage. Furthermore, S3 supports various compliance programs, making it suitable for regulated industries. So these are the security features like encryption, access control, monitor and logging, and compliance. How to manage the data in S3. So managing data in Amazon S3 is very straightforward. So with its various features like versioning, for example, so versioning allows you to keep multiple versions of an object, making it easy to recover the previous versions, so if needed. And the lifecycle policies help you to automate transitions between storage classes, optimizing costs based on the data access patterns. And there we have replication, so which enables you to replicate your data across different regions, for the added redundancy and disaster recovery. And for the faster uploads, you can always use S3 transfer acceleration, which leverages Amazon's global network to speed up your data transfer. Moving on. So that's about the introduction to the Amazon S3. So I have kept it simple and straightforward so we can understand the basics of the Amazon S3 simple storage services. So now just to show you how to create a S3 buckets in Morpheus. So I will walk you through the steps for creating S3 buckets in the Morpheus. So Morpheus is our cloud portal where you can manage all the instances and create the buckets. So here I'm going to show you how to create them. So here it involves several steps. So first is accessing the cipher. So basically you have to navigate to the cipher within the Morpheus by usually going to the tools and then selecting cipher. And here you will find your keys. In your tenancy, you will find your keys, bucket access key and bucket secret key, which are very important when you actually set up a S3 bucket. So setting up a storage, next you have to go to the infrastructure section and then select the storage. When you click the add button, you can select create a new bucket, and then you can enter. So right now I am at this slide, create S3 buckets in Morpheus. So no,
Maybe reshare.
slide. So you see slide 8. I am at slide 9. Yes, that's right. Yeah, create S3 bucket in Morpheus. So is everybody on the same page?
So we're on slide 8, managing data in S3.
Can you see me changing the slides?
No, it's still the same. Can you stop sharing and try sharing again?
Yeah, okay, I can do that. Stop sharing.
So we see slide 1 now.
Okay, I'm gonna resume. So you should see slide 9.
Yes, thank you.
Okay, no problem. Yeah, and yeah, apologies for this. Yeah, okay, no worries. Yeah. So yeah, to continue with this, so as I said, from the tools and cipher, you basically get your access and secret key for the bucket, which you have to use to create the bucket. And then, when you click the add button, you give you all your information inside the bucket and then create a bucket. It's very straightforward. I'm going to take you through the demo as well in the next slide. So we have our endpoints. So if you are creating a bucket at EUMetSet, so you have different endpoints than ECMWF. So I have listed those as well, but you need not to worry. So everything is documented under our knowledge base in Confluence page. So whatever I am showing you right now is already documented, and anyways, the presentation is also getting recorded and will be shared to you soon. So yeah, so these are the endpoints of the for creation of the bucket. So we just have to note down the secret access and bucket keys plus the endpoints. So these are important for creating the bucket. So now I'm gonna take you through the demo for the creation of the bucket. So basically here you have to go to tools and cipher, and you can see the bucket access key and secret key available. When you decrypt it, you can see the things and you copy those keys and go to infrastructure, storage, and here basically you give in all the details. Like the name has to be unique for all the buckets, so it should not be repeated, otherwise it will not create. So you have to give the unique name for this. So I am taking here as object storage demo. So I am giving the same name just to avoid the confusion as a bucket name. And for the service, I'm selecting the tenancy object storage. You can select your region, and yeah, URL is important. So in whichever side you are, so the URL is important. So you give the endpoint URL, and then yeah, that's it. You click and yeah, it's simple and straightforward, and there you go. You have created your bucket. You can now use it. You can configure it according to your needs, and yeah, you can use these buckets to manage the S3 stuff. And yeah, you can also delete if you're not needed by using this simple steps. So in Morpheus, it's pretty straightforward how to create the bucket. So you just have to note down the keys and then the endpoint, and then yeah, you are good to go with the creation of the buckets. So yeah, this once you set up a bucket, now I can show you how to do this management stuff using the different types of tools, using AWS CLI as well as with the Jupyter Lab, which was created by Samuel just before this. So we are going to use this, and we are going to see how we can use this stuff. So here in this tutorial, I'm using like S3 CMD, S3FS, rclone, AWS CLI, and Boto3 for Python. So yeah, to begin with, S3 command. So S3 command is a command line tool for managing S3 data buckets and objects. So first we will ensure like all the like the package, like S3 CMD package is installed, and then we can go to the use cases, like for like example like bucket management. We are going to create list and delete the buckets using the command, and we are also going to manage some of the objects like upload, download, and list the objects. We are also going to do some of the lifecycle management, like for example, set lifecycle policies, expire, and delete the life cycles. So yeah, we are going to see that in this demo video. So here in the beginning, first I have to make sure if the SD command is already installed. So it is already installed. If not, you can use this apt install according to your OS, and you can install it. And then later I am going to configure it. So basically this configuration needed is access key, secret key, and the endpoint. These are the important part. And once you have all these three keys, and I am keeping the rest as default, so you can test these keys if it actually works in the environment. And yeah, I am keeping everything default and testing the access with this credentials. So once it is successful, it says like success, your access keys and worked fine, secret keys. So you can save it under .s3 config files. You can reconfigure it with your keys. Otherwise, we can move on with the management of the S3 keys. So here I am listing some of the buckets available, and I am actually creating them using the MB. So make bucket. So make bucket, giving the unique name OS EWC. So now the bucket is created using S3 command. So when you list it, you can see the bucket is created there, OS EWC. So that's how you can create a bucket and list the buckets in the system. And yeah, you can list it. You can see OS EWC is created. And now let's write something to a file. So I am writing this is a sample file content just to upload this file to the bucket. So I am gonna use put command to upload the file inside the bucket, and then I am going to list if the file is actually there inside the bucket. So now I am going to list it using ls command, and then inside the bucket. So it shows like yeah, the my file text is already uploaded. So this way you can use it to upload the file or to the bucket. And then I am gonna use, now I will be using for you to show the information about the bucket. So using the info command, so here you can see what information the bucket holds. So you can find out the expiration, you can find out the location and ACLs, so everything. And now I am setting the policies, the expiry policies of this bucket. So it's like 14 days I have set it. So if you see the information again, you can see the life cycle policies of this bucket. So after 14 days, all the files will be deleted automatically. So it is helpful for the management of the buckets. So that's how you can do it. You can, if you do not want to have this automated management, you can always delete it by using a delete life cycle. So yeah, once you do that inside the command, so your life cycle policy will be deleted. And as you can see the information, so yeah, here the expiration policies has been deleted. So that's how you can use these tools to manage your data and interact with the storages. So yeah, once you list it, yes, now you can see the file there. Now if you want to remove that file, the data, that you can also remove it by using the remove command. Yeah, rm command with the s3 command, and then you can easily delete your file. And when you list it, you can actually see the yeah, there is no data present in the s3 command. So moving on to our other tool, S3FS. So S3FS is one of the command line tools, which is a fuse-based file system, which is backed by Amazon S3. So it allows you to mount an S3 bucket as a local file system. So for example, imagine you have like large data sets stored in S3 that you need to access and manipulate, and as if they were like your local files. So this S3FS enables seamless interaction with the S3 storage into your local file system structure. So for this, you can use your S3FS. So let me take you to a quick demo for setting up this. So yeah, as usual, I'm gonna make sure the S3FS is already installed. So if not, you can install it by using this command. And once the S3FS is installed, so you can always use the echo command to write the S3 access keys and secret keys to the .password minus S3FS file. So once you write it to the file, you can give the permissions, like use the permission, set it to chmod 600, which changes the file permissions to make it readable and writable only by the root users, ensuring that the credentials are secure. So after that, you can create a directory where S3 will be mounted. So this -p option ensures that all the necessary parent directories are created. So that's why I am using that. And once done, you can always use the echo command to add the entry to the fstab file to mount the S3 bucket at startup. So once it is there done, you can just mount it, and you have the you can verify it later. You have the mount ready for your bucket with the URL. You can also use the options like allow other to allow the non-root users to access the mount. So now to verify the mount, you can list it. So when you list it, you can see actually, so it is already mounted, and you can verify that the mount is successful. So you can use this command. It's a cool way to mount the buckets. So here I have used this EUMETSAT rainfall data just to see if everything works. This is already ready-made workflow, which you can find in the documentation as well. So now moving on to AWS CLI and rclone. So basically, AWS CLI is like a command line interface which provides comprehensive control over AWS services. So here also we are gonna do some of the basic operations like to configure the AWS credentials, to check the bucket operations, and some to access some of the public buckets. And regarding the rclone, so rclone is another command line program for managing files in the cloud storage. So here also we are going to see the installation of rclone and some of the use cases like configuration, set up a cloud storage provider like rclone config, and then we are going to see some of the file operations, for example, copy and sync the files between local and the remote storage. So I am starting the demo. Yeah, first, we are gonna install the AWS CLI. So once it is done, it's all good. So once you have the AWS CLI, now you can configure it by using AWS configure, and basically you have to give the access and secret keys and your default region. Otherwise, you can put it default, and then the default output format is none. So I'm not giving anything. So here you just need the keys. And once you have the keys, you can already list the public buckets here. So this is also one of the bucket. I got it from the EOMetsat ready-made workflow, which is already mounted here. So I have used the endpoint URL, and then I have used the bucket to access this without any sign-in request. So it basically, this flag tells you that the AWS CLI is AWS. It does not need a sign-in request. This is used for accessing public S3 buckets, and you do not need AWS credentials for that. So we have used endpoint URL, which specifies the endpoint URL for the S3 service, and with the AWS S3 LS, we are gonna list the contents of the bucket. As you can see, I have listed it. Yeah, so moving forward, just to look how this rclone works. So basically, I am installing all the rclone stuff, and then I am going to do the config files. Here, I have already created the remote file S3. So I am gonna use that just to show you how it works. So basically, it needs some of the configuration to provide necessary credentials and set default options for other settings. So access keys, secret keys are important. So type is S3 bucket, as we are using that. So these keys are important, and endpoint as well here. So these are the important stuff, and the rest I am just giving as a default option for the other setting. And yeah, just giving default ones, and then default again, and just checking if I have given the right one. So ACL is public read. So I'm not gonna edit any advanced configuration, and that's it. Yeah, I'm gonna quit it. So we have the remote already. So we are gonna list if we are successful in listing the remotes using rclone. Yes, we are successful. So we have S3 here. So as you can see, we have S3. So that's the remote one. And now I am going to create a sample file using the touch command, say myfile.txt. So using that, I am going to upload the S3 bucket using rclone copy. So when I use rclone copy, it's basically uploads the file to the S3 bucket. Yeah, the S3 bucket which I have created before OS EWC. So it has been uploaded, and now I am going to create a local directory and sync it with the S3 bucket. So it's already exists. So I am going to use the same directory to sync this directory with the S3 bucket using rclone sync. So this command ensures that the content of the local directory matches the remote bucket. So including all the files which are not present locally. So that's how you can use to copy and sync the files using rclone. So moving forward, so Boto 3 is basically Amazon Web Service software development kit for Python, which allows for seamless integration and programmatic access to AWS services. So to give an overview, it's like a AWS SDK for Python. It provides an easy to use API to interact with the AWS services, including S3. So here you need the packages. Boto 3 should be installed already, and then we can use the use cases to write a script to automate S3 operations using Python, that is Boto 3 client. And we do some data manipulation. For example, we read, write, and process the data in the S3 buckets. And then we do some integration stuff, integrate S3 with other Python libraries. For example, to visualize the data, we can use matplotlib for the data visualization. And also you can always see that as well. So yeah, in the demo for the CLI, I am showing this Python demo. So here I am setting up the script. So we are gonna import this Boto 3 package, and then we are gonna initialize the S3 keys, S3 client, using the endpoint URL, your access keys, and secret keys. That's how you can initialize the S3 keys. Once this is done, I have also taken the S3 bucket name as my S3 demo bucket. So I am going to use that for this script, and then basically when you run the script, it has to initialize the S3 client, and then we can then I am trying to create a bucket using this command, and when you run the script, the S3 script, you can actually create a bucket with the Python script. So yeah, and we can also use the other types. For example, now I am going to take yeah, I am going to delete the bucket thing, and I'm going to take other script to create a sample file and upload the file to the bucket. So this script is already there, so I am just copy pasting it just to show you how this works, the Python works in the CLI for the buckets. So once you run the script, you can see that the file is created and it is uploaded to the sample file. So yeah, with this, we can also include even more stuff. For example, here I am also doing some of the I'm using other script to list the objects in the bucket. So here we are basically printing the objects in the buckets. As I have uploaded some of the files to the bucket, so you can see I can easily list some of the objects, and then I am also using it to read it from the memory and then download that same file from the bucket. So we can see many other things doing this. So you can always use this script to automate your integration with the S3 buckets. So as this script says, you can easily say that this file and object, it has already downloaded also the same sample file. It has it has also listed, it has downloaded. So that's how you can automate your Python script. Yeah, of course, you feel free to use the script according to your requirement. And now I am going to show you how to read the data of one of the EUMETSAT data bucket. So which is of the form netcdf. So we need this netcdf installed also, a package. So you can do pip install netcdf, and then you can import this data set from this. So I have taken one of the EUMETSAT bucket here to show you how to read some of the EUMETSAT data. So I have taken the bucket name CMSUB cloud type, and then I have taken a particular file key just to show you, so we can also read it via the script. So once you take the script and give the bucket name and run the script, you basically read this particular file of the netcdf format. So yeah, I'm running the script now. Yeah, so now as you can see, you can read the data of the EU method, one of the EU method buckets using the Python. Yeah, so that's about the Python. So now moving to the Jupyter lab. So for the Jupyter notebook integration, so it provides an interactive environment for Python development, which is capable of accessing and manipulating data. So here we would need a Conda environment, and then we have to basically start the Jupyter lab. So in the demo, I'm just going to show you how to start the Jupyter lab. So first, we have to activate the Jupyter using the Conda. And then once you are inside the Jupyter, you can basically, start the Jupyter lab by using like Jupyter lab command. And then once you hit it, it actually starts. And then right now I do not have the browser installed, so it is going to install. So I'm going to use any of these two commands, any of these two URLs, and paste it in your browser. And once you pasted it, you can already see there that the browser is set up and installed. So I am basically pasting this. This will be present in another slide where I will show you later. So once you paste and run that link, and now you can see the Jupyter lab is started. So so here it has already started. So I am going to take a new notebook with the Python, and then I am going to start my stuff here. So start doing the, so basically I am using the same script which I have showed you in the Python CLI. So I am importing the Boto3. I am initializing the client. So the S3 client. So once it is done, I'm using the same part of the script to make the buckets, to create a bucket, to list the objects, to upload, and to download the stuff. So I'm using the same script, but the environment is different. So I'm using the Jupyter here. So Jupyter lab to do this. So basically it initializes and fetches, and then it creates the S3 bucket, and then it uploads the objects and files. So whatever I have used in the CLI, I'm using the same chunk of program, and then I am gonna list the objects and stuff. Right now it shows bucket is empty because there is none of the objects were present. But when I convert those into the contents, so then you can see the list is there. So I am basically using one of the script to list the content of the file which was uploaded to the S3 demo bucket, and it is now showing, it is listing what is there in what objects are present in the bucket. And then to download the file, so yeah, so this is the one I am using. So this script to download the file, so it says like, hello, this is test file, which is created in the memory of the S3 bucket. So yeah, that's how you can use the chunks of the folders to create one. And yeah, to list the objects from the EU method bucket, so I am taking the same example to list the EU method bucket, to list the files of the EU method bucket. So the same script chunk of the programming. And then yeah, this is how, so I have taken the bucket name, the same bucket as I have used before, CMSUF, and listing the objects inside this bucket. So once I press, yeah, you can see these are the list available in the bucket. So yeah, this one As I said earlier, so it is available in the knowledge base. So all the mount points and the data buckets are also available there. So it is easy for the ready-made workflow. You can use this. So that's how you list it. And to read the file, so I'm using also the same part of the script and of the Python script, and then I will run it to visualize to read this data. So to read this data, this is not visualizing, this is reading. Visualizing, I will show you in the next slide. So so that's how you read the data. Basically, I have used the same script in both the CLI and Jupyter Lab. Yeah, you can read the data like this. And yeah, last but not the least, I will show you how we can visualize the data here. So basically, I am going to go select the new one, and then I am going to put this script. So it basically imports some packages, and then it is so this one I am particularly taking this netcdf format, and I am using matplotlib to visualize the data. So I have taken this EUMetsat cloud, it was mounted directory, and one of the files from that mounted directory. So basically it mounts the directly and constructs this file path, and then it opens the netcdf data set from that file path, and it prints information about the data set, including the variables and dimensions. So after that, it searches for a two-dimensional variable to visualize. So in this case, it has selected CT, the cloud type, which represents the cloud type. So this is the variable I have given. So when the suitable variable cloud type is found, it extracts the data from this variable, and then it creates a figure and uses plot imshow to visualize the data, and 2D data as an image with the color bar representing the value of the CT variable. So the title of the plot is set to cloud type visualization, which is derived from the long name of CT variable. So finally, it displays the visualization using the plot.show. So the x-axis, y-axis are set to x-axis and y-axis respectively. So that's how you can visualize the data, and it basically reads and visualize this. So it shows the 2D image where x and y axis represents the spatial dimensions. The color scale is also represented by the color bar of the cloud type, corresponds to different cloud types as categorized by the CT variable, which ranging from cloud-free conditions to various types of intensities and cloud cover. And yeah, that's how you can visualize the data. And yeah, so in summary, I would like to say that these tools provides like versatile and powerful ways to interact with the Amazon S3, which are suited for different use cases. So S3FS will make accessible as a local file system, whereas S3 command offers an extensive command line management capabilities. AWS CLI allows you to allows you for the comprehensive AWS service interaction, whereas rclone it excels in data transfer and synchronization. And Boto 3 provides seamless integration with Python applications. So understanding and these tools can greatly enhance your ability to manage and utilize the S3 storage effectively. So yeah, so that's about the tools which I wanted to show you. So do you have any question, Pierre, or should I like wind this up?
Hello? Can you ask a question on the microphone?
Yes, please.
Yes. One of them I have is there a performance difference between using S3FS or AirClone or other tools, and are these recommended if you want to make like processing of climate datasets?
So basically, these are like S3FS, S3 Command, and AWS CLI, rclone. These are the command line tools, so which you can able to read the data, get the data, and manage whatever I have shown in the demo. But in order to visualize the data, you need to have a specific library. For example, here I have used matplotlib to visualize it. So I have used Jupyter Lab. Using that library, I can able to visualize and see the data. So
my
that's the
question
difference.
is whether there's a performance implication of this choice when processing terabytes of data.
Maybe I can answer from my part. Good morning, everyone. My name is Roope Tervo, coming from EWC. So there are some differences in the performance-wise between, let's say, so-called traditional storage and object storage. And I would say that the key difference in performance-wise is that you introduce a bit of overhead because the protocol is over network. So you have a bit of overhead reading individual file. But at the same time, the object storage is accessible from over the network, so you can very easily scale your process to the multiple nodes, multiple servers, containers, whatever you are using. And object storage scale very well in responding countless simultaneous requests, and provides better performance in that case than NFS, for example, doing the same work. But it depends on the use case. Of course, we then some specialized environments have also other file systems like Lustre and others, and there's no total one size fits all.
Okay, thank you.
I would also like to clarify a few points on this presentation. Urusa gave a presentation on general S3, Amazon S3, and the name Amazon comes from that the protocol is introduced originally by Amazon. But we are in EWC, we are not using Amazon, but we use Ceph as a backend. And that means that a couple of things. First of all, we do not have all the functions what Amazon is introducing. Most of them are there, but not everything. And second, we do not use pay-as-you-go model in European Weather Cloud. We are obviously flexible, and we have our own accounting scheme in EWC, but that is not pay-as-you-go as Amazon advertise it. And third thing, what I would like to clarify from that, I would not recommend to use this particular implementation of object storage for long-term data preservation. So it is used for data processing. You can save your data there, but we do not take backups from the data automatically. You have to take care of that, and that is used for meant for operational storage, not long-term data preservation like data archives are. I believe we have some questions.
Yeah, another question. Thanks a lot for the creation of the bucket. I wanted to know whether it's possible to use infrastructure as code like Terraform to be able to create the bucket and automate it and be able to reproduce it afterwards.
Can we use Terraform, Roope?
Yes, in terms of yes, I think it should work using Terraform for other parts of the EWC infrastructure is still something what we are working on. But for object storage, I would assume it works, and maybe some others can comment if you know directly that it works or not.
Yes, and just to add to what Rope was saying, maybe another option is to use things like Ansible as well. So you can use Ansible to manage your buckets and all that if you have your workflows already integrated in such tools, such automation tools. So that this is definitely possible.
Okay, thanks.
I would also have a question. Thanks for the presentation regarding these bucket creations, because I did create some buckets from the virtual machines with these S3 common make bucket, but they do not appear in Morpheus. And I was wondering if that makes a difference somehow if you create your bucket from Morpheus or from your, let's say, instance on the your cloud.
I think it's supposed to not make any difference, because anyways, for creation, you would need the keys. So even if you create in the Morpheus and if you want to access it from the CLI, you can do that. Or if you want to create it from the CLI and use it, you can do that as well.
Okay, thank you.
So I have a question on the credentials for the buckets. So what you have is that you have one pair of access key and secret key in Morpheus, and that is, if I understand well, what you are supposed to use for creating buckets and for accessing the buckets. Meaning that if we share the credentials with users, of course, it's a limited set of users in the tenancy. That means there's only one set of credentials and no way to fine-grain access to say read-only or to a specific bucket. Is it correct?
Yeah, so this is the basic set of credentials we provide for every tenancy. But if you request for different types, like for example, read-only policies keys, then of course we will create for you that read-only and upload-only, for example. Then you can use it for your use cases. Yeah.
Okay. And so could I, for instance, request read-only credentials for project partners so that they would have read-only access to the buckets, even though they are not otherwise users of the weather cloud?
Yeah, if they are not admins, then then they only have the read-only access.
Okay.
Yes, that's possible. You can then set the corresponding bucket policy to your buckets and share those keys to totally outsiders as well. And those keys, if you set up the bucket policies correctly, would have only read-only access. Okay, so it's a combination of extra credentials and of bucket policy then? Yes, indeed. Okay. So how it works is that at the moment you unfortunately have to request for additional set of keys, which we can create for you, and then you are then responsible for setting the bucket policies accordingly. You can also create other bucket policies, like just writing policies if you want them to upload data to your bucket, and so on. So okay, thank you.
Just to complement on Rope's answer as well. So when those extra sets of keys are created, we can also do them already read-only, so that then by default they will not be able to write in any of the buckets. Yeah, and then on top of that, you can also fine-grain via policies if you want to restrict them further, maybe access to a specific bucket or specific parts of the bucket or files in the bucket, and so on.
Oh, okay, thanks a lot.
That might not be, at least this is for sure possible on the ECMWF side. I don't know if it is possible on the EUMETSAT side, but in any case, via policies, then you can make sure that you get the right access to the relevant accounts.
Okay.
And one thing what I forgot to say, I could add to the performance question, which very good question. Just to note also that using this S3FS mounting using Fuse system, the bucket, it is quite convenient because it provides file system-like view to the bucket, but typically, unless you very carefully set the parameterization right, it doesn't provide very good performance. And I think in practice, it never provides good performance in listing files. So typically, as a thumb of rule, I would say that you get a better performance by using the buckets directly from your workloads, from your Python scripts, for example.
Okay.
Plus, I would say that there are some tools and libraries that can already speak S3 directly. And if that is possible, that's always preferred. And then, because then you have that direct access to the actual files, and you don't have to mount anything or specify and go through any intermediate tools or libraries.
Yeah, so for satellite users, for information, SatPy, for instance, allows reading data directly from S3 buckets. So if anyone is using SatPy, you can give a full S3 path instead of mounting the file with S3FS. So I've tested that already.
So yeah, okay. So I wanted to keep the questions at the end of the slides. I just have some more information to give it to you. So I will continue. This is the general information which I want to share you. So the things which we did in this presentation is already documented and you can find it in knowledge base. So it's our Confluence page. So basically you can use this link or the barcode to access it. And if you scroll down to EWC data access, here you find all the information and all the documentation regarding this object storage. So yeah, you can always see the other stuffs as well, not only data access, but other stuffs are also being documented there. So we use this Confluence page, so you can check out the documentation. And yeah, so if you have any questions, you can reach us out with our support portal. Basically, one way is to reach it with the Morpheus. In the Morpheus, at the top right corner, you can see the support button. So from there, you can easily, open the ticket, or you can also use this link and the barcode for the for the official support as a ticket, so you can get all our official support there. And last but not the least, we have a discussion platform, Rocket Chat. If you have not yet registered, we would suggest you to register there, so you can have all the latest information, and everybody from EWC like ECMWF and EUMETSAT are available there. So you can contact us if you need any quick support. We also have different channels like peer support and general, so where we update what's going on in the EWC, as well as we update in the Confluence page, the knowledge base as a blog post. So you can always check that out. And yeah, this is the another way to contact us with the support at the rate. This is our official email to contact us. So you can always send us the email if you need our help or if you need some information. You can use the knowledge base. Even if you don't get the solution there, you can ask us from the Rocket chat, or just ask us, you know, by official support tickets. There you will get the official support. So yeah, I think that's about this presentation. So I hope this is useful and informative for you all. If you have any more questions, you can ask us, or you can use the chat or the Rocket chat. Anywhere we are there, so to answer it. So yeah, I hope this session was informative and helpful for you, at least a little bit.
Awesome. Thank you so much for everybody's questions and for the presentations. Really, really interesting. Thank you all. Yep, and see you at the next one, which you'll find online. Find details about that shortly.
Thank you, everyone. Have a nice
Thank
day.
you.
Bye.
Bye
Thank
bye.
you. Bye.
Bye. Thank you for the